In this lesson, we'll be proving midpoint properties of trapezoids. Namely, we'll look at how the length of the line segment joining the midpoints of the non-parallel sides of a trapezoid is equal to the mean of the lengths of the parallel sides. The question reads, given the coordinates A, B, C, and D, investigate the properties of the midpoints of the non-parallel sides of a trapezoid. The first thing that I'll do is plot these points. Our first point is A, which is at -2 and 2. That's right here. Our next point is B, which is at -1 and +2. C is at 4 and 2. And D is at 6 and -2. Let's go ahead and connect these. As you can see, once we've connected these points, this side and this side are parallel. What we're investigating here is how the length between the midpoint of this point and this point, which is somewhere here, connecting a line from here to the midpoint of this side, is equal to the average of the length of the parallel sides. So technically, we have to find the midpoint for this side, find the distance or the length of that line, and then find the length of the line for here and here, take its average, and see how it relates. Let's go ahead and do that. Let me start by labeling these points. Now that I've labeled my trapezoid, I'll go ahead and find the midpoint between A and B. I'll show you how to do this one, and then you can use the same method to find the midpoint for C to D. The midpoint is the average of the coordinates. So the midpoint between A and B is equal to the average of the x's and the average of the y's. The x-coordinate for A is -2. The x-coordinate for B is -1. Divide that by 2. Then we have -2 plus 2 divided by 2. This is equal to 0. -2 plus -1 is -3 over 2. We can plot that, and that exists right about here. So I'll write that down. We have -1.5 and 0. Remember, -1.5 is the same thing as -3 over 2. Also, I've provided the midpoint between C and D, and it happens to have the coordinates 5 and 0. Now it's time to find the length from this midpoint to this midpoint. To find the length, we use the distance formula. The distance formula is the square root of the difference of the x-coordinates. So we have x2 minus x1 squared plus the difference of the y-coordinates. The x-coordinate here is 5 minus -1.5 squared plus y2 is 0 and y1 is 0. So we don't have to worry about that part. Now using our calculator, we have 5 plus 1.5 to the power of 2. We're going to square root this number. We end up with 6.5. So the distance from this midpoint to this midpoint is 6.5 units. Now we have to find the distance between B and C and the distance between A and D. Take their average and compare it to 6.5. To find the distance between B and C, that's easy. We don't need to use that distance formula because we can just use visual inspection. We have 1, 2, 3, 4, 5 units. And the distance between A and D is 8 units. Let's add these up. 5 plus 8 divided by 2 because we are taking their average. We end up with 13 divided by 2, which is equal to 6.5. Therefore, to conclude, the line segment joining the midpoints of the non-parallel sides of a trapezoid is parallel to the parallel sides and has a length equal to the mean of the lengths of the parallel sides. So this line, which I haven't drawn, is parallel to the parallel sides as well.